One of the formulas that we actually encountered already is the first one there, namely, if you do x squared minus b squared, no, excuse me, if you do x minus b times x plus b, you get x squared minus b squared. We actually encountered this when we did multiplication. But this gives us a method of factoring. Basically, if you have a polynomial of the form x squared minus b squared, this tells us how we can factor it. You write it as x minus b times x plus b. X minus b times x plus b. And you can do that for any number b. So for instance, if you had x squared minus 9, right? You can factor that easily from this formula. We have x squared minus 3 squared. And you end up getting x minus 3 times x plus 3. Okay, so that's what we get here. We have x minus 3 times x plus 3. Same thing also with x squared minus 36. Right, we have x squared minus 36. Well, 36 is a square. Namely, excuse me, it's a perfect square. Namely, we get 36 is 6 squared. So we have x squared minus 6 squared. That's actually what we hear. Hence, from this formula with 6 as b, we get x minus 6 times x plus 6. So let me say it again. If we have a polynomial that fits this description, it's x squared minus a perfect square. So x squared minus b squared for some b. Then we can factor it using the formula. And that's what these are showing you. You know, for the first one, b is 3, so we have x squared minus 9. And for the second one, we have x squared minus 6 squared. So it's just another way to factor. It's actually what they call a difference of perfect squares. Note that if you have a sum, x squared plus b squared, so here we have a sum of perfect squares, right? It turns out you can't factor this. Mostly because we're not dealing with complex numbers. So you cannot factor this. Okay. Now, this is actually, this is the method for the next factoring method. These are the steps, that is, for the next factoring method, which we call factoring by grouping. And this is actually what you're going to use if you have 4 terms. So if you have a polynomial where there are 4 terms, this is what you're going to use. The first step is actually, well, the first step is kind of optional, where you have to find and factor out the GCF. It does make the process easier, but it is kind of optional. You'll see when we do examples, it's going to make more sense. What you do first is you're going to create 2 groups of 2 terms each. So again, we have 4 terms, right? The first 2 terms will form your group, your first group. Then the third and fourth term will be another group. When we do examples, it will make sense. Then you factor each of those 2 groups individually. You will factor each 2 groups individually. And this is something actually a student showed me this trick, that if the second and fourth term have different signs, so one is plus, one is negative, or the other way around, you have to factor out a negative from the second group. Whatever you factor out, it has to be negative. You know, so it could be just -1 you factor, but at the very least, you factor out -1. Because what's going to end up happening is after step 3, what you want to happen is, in parentheses, you want to have the same factor. Then you factor that out, and you'll get, basically what you're looking for. I know you're probably thinking, what on earth is he doing here? When I do examples, it will make more sense, which I'm going to start now. So let's suppose we had this. So notice here, we have 4 terms. Okay? So we're going to use factor by grouping. Okay, so let's find the GCF. I mean, if you can find the GCF, it's good to factor it out. It does make the process a little bit simpler. But here, notice the GCF is 1. And I really just wrote down why, right? The leading coefficient here is 1. Okay, that tells you the greatest common factor among the coefficients and the constant term is 1. So in other words here, that bx to the m, that b is 1. And since there's a non-zero constant term, you can't factor out any variables. So basically it boils down to this. The leading coefficient is 1. The non-zero constant term is also 1. So because of that, the GCF is 1. Okay, that's step 1, right? That was step 1. Find and factor out the GCF. Now, what we're going to do is we're going to create 2 groups of 2. That's what these parentheses are doing. This is our first group. Here's our second group. 2 groups of 2. Okay, good. Now we have to factor each of these 2 groups individually. So here's the first one. Now, right away, you should be able to see we could factor out x squared, right? I mean, if you were to find the GCF of this group, you would get that the smallest exponent of x is 2. And since the leading coefficient's 1, that tells you b has to be 1. So we can factor out x squared. Is this making sense so far? You can be honest.
Yeah.
Okay. But again, we're going to basically factor out x squared. Okay. So when we factor out x squared, that's what we're doing here. I mean, yeah, the GCF of this thing is x squared. We're going to factor it out. What are we left with? Well, we have to divide. Okay, so we divide, as you can see, right? We divide into each term, like so. And what happens when we divide? Well, remember, when you divide, you subtract the exponents, right? You have x cubed over x squared. That gives you x. You subtract the exponents. 3 minus 2 is 1. Here, the x squares cancel, so all you're left with is 5. So the first group here, we factored. I mean, yeah, we factored out the GCF. Essentially, it boiled down to taking out common factors. But now we have to factor this group. And before we get to the next slide, what would the GCF of this be? Can anyone see?
3.
It's going to be 3, right? And how do we know that? Well, notice there's a non-zero constant term here, right? So you can't factor out a variable. 3, the only factors of 3 are 1 and 3. The only factors of 15 are 1, 3, 5, and 15. So 3 is the greatest common monomial factor of this. So we factor out 3, as you can see. Right? We divide, put it in front. We divide into each term. Right? The 3's here cancel. 15 over 3 is 5. Now, even before the next slide, what you should notice is this. Let me get to that pen, the magic pen. Okay. Notice that we have the factor of x minus 5, and from the second group, we also have x minus 5. We have x minus 5. That's good. In other words, in these two parentheses, right, from these two groups, we get a common factor of x minus 5. And that's what we want. We want some common factor among the two groups. Well, if there's a common factor, what do? Factor it out. And that's what I'm doing here, right? When you factor it out, it's just like before. You put it out in front, you're going to divide into each term. Okay? You're going to divide into each term, and that's what these steps accomplish. You divide into each term, right? The x minus 5, let me get that pen again. It cancels. Here, it also cancels. And we get x squared plus 3. And so altogether, finally, we get this factorization. And I know that was involved. I understand that. This is going to take practice. This is not easy. I understand that. I mean, I hope when I was explaining it, it made it more understandable. At least I hope so. But that's basically it for today. So let me stop.